kind of going back and forth, okay? So remember, you add these up to come up with your total. That should just be one number at the end of the day. So let's go to page 17 here. And deck of cards, marbles, spinners, they all come with us, okay? Watch how I'm going to do these. There's a certain trick that I use for odds. Okay, so you ready? Just pay attention and try your best, okay? The spinner below, use the spinner to answer the following. So it's asking us for the odds of the spinner landing on green. So watch this. First of all, it says odds. The second thing it says of, it doesn't say against. You notice that? Of what happening? Of you wanting green, right? That means you're going to say, okay, that means that the possibilities for grabbing or it landing on green will come first, and on the other side will be not green. Remember, I put the bar on top sometimes? That's also the same, but we can write it either way, right? I did the bar with you, right? Some of you are thinking of a different bar. Yeah, think probability right now. So green, you grab a green, right? How many greens are there? 2. Focus on that. So that'd be 2. What would be on the other side? I'm going to show you a trick. This is a small scale. It will get bigger. It'll get into the thousands. You ready? 1, 2, 3, 4, 5, 6, 7, 8, right? Total outcomes would be 8. Okay. But we're not doing probability, Mr. Dixon. I don't need my total. Well, watch what I'm going to do. If 2 are green, then 8 minus 2 would be not green. Do you agree with me? 2 to 6. I'm not going to reduce it today, but you reduce odds just like you do a fraction. You divide both by the same number. Divide this by 2 gets 1. Divide this by 2 gets you 3. It'd be 1 to 3. It doesn't matter. It's saying the same thing. Okay? So this is how you got your odds. It's saying 2 green and 6 are not green. That's what odds do. Okay? Okay. What's the probability of the spinner landing on green? I don't want you to use the spinner right now. If you can, cover it up. I'm going to cover up my spinner for now. Put your hand on it. Okay? If all you had was the odds of green, like this, how could you come up with the probability of green? You go like this. Probability of green. What's the first thing you're going to do? Add them. Sorry. I need water. Add them up. 2 and 6. 2 plus 6. Show that step. I don't know my spinner, but I know the odds of getting green, so that's all I need. So I'm going to go 2 plus 6, and which of these 2 numbers am I going to grab? I determined that the left number is green, so I'm going to grab the 2, put it on top. So that is 2 over 8. Okay, so the odds are 2 to 6. The probability is 2 out of 8. This is a total. Okay. Is there total here for this one? You see 8 anywhere? You should not. If you do, you made a mistake. Okay. When you add them up, you should get the total. Yes, that's true. Okay, let's keep going. You can put your finger off the spinner now. You can look at it again, right? So what are the odds? You got to read carefully. Probably answering is quick, but you need to read before you answer. The odds of the spinner landing on red. So you want that to happen. In favor. Write that down. In favor. If it says the odds of, it's the same thing as saying what are the odds in favor of it landing on red. That's the desired outcome. So that means that you're going to have red, and here you're going to have red with the bar on top, right? So how many reds? You go look. 3, right? Yeah. And on the other side, look at my trick, not red. So that means I take the total and I subtract the 3 from it. That's the best way to do it. Just trust me. Okay? 3 to 5. What is this saying, the 3 to 5? What is that saying? It's saying that if you had 8 marbles, 3 of them would be red, 5 of them would not be red. They could be white, blue, black, whatever. We don't know that, but we know that there's 3 reds to every 5 that are not reds. Okay? Okay, state the probability of the spinner landing on red. So I did that for a reason. I do them side by side for a reason. Okay, so probability of red, how would you do that? Take a second to do that. Answer this question right now. Should take you 20 seconds. If you just follow along today, we just won't do an AC. We'll just do this, and I have a little bit more to go yet. This works exactly the same with cards. It works exactly the same with anything I throw at you. Right? This could have been 20,000 to 100,000. Steps stay the same. You add them up. That's your denominator. And then you just need to see, based on how it's worded, which of these two numbers do I pick to put on top here? Okay. So this would be 3 plus 5, right? You add these up, and then you'll go 3 on top, right? So it's 3 out of 8. Question. Pay close attention because I can't cover everything. If I gave you these two odds, would you be able to right away tell which one is more likely to happen? It's hard. It's harder. But if you look at the fractions, can you tell which one is more likely to happen? This one, right? You could even turn them into decimals or percentages. So whenever I give you two odds, you should be converting them to probabilities and actually state them as a percentage. Then you know which one is more likely to happen. Okay. I don't want you to just be like, well, let me see, right? Like I don't want you to guess. I want you to use the skills to transfer. Let's keep going because I'm going to do the against part now. I want the odds. So right away you should be thinking odds, think 2 dots, right? Against yellow. Against yellow. Not in favor of yellow, against yellow. That means that you'll put yellow here. Watch this, right? You put yellow against you, and so what goes on in this side here? It's always yellow, not yellow, right? So if this is yellow, then this is not yellow. This is because of that word right there, odds against, right? Against yellow. So you put yellow. If you're reading this from the left, right? Yellow is against you, so it's on that side there. Which one would you fill in first? I always fill in the event, and then I worry about not the not part. Okay, so how many yellows are there? There's one. So how many are not yellow? 7, right? We know it's 7, but I'm going to do this. Total minus 1. So I'm going to take 7 to 1 like this. This one cannot even be reduced any further. That's just as reduced as it gets. There are 7 not yellows to every 1 yellow. That's how this reads. Okay. So watch this. You ready for this one? I want you to do it. The probability against the spinner landing on yellow. So you're basically finding that probability. And then I also want you to do G and H. Okay? So do F, G, and H right now on your own. And if you're done, keep going, but I will give you some more instructions after this. Okay? So there you go, that's it filled in. Let's keep going here. So I need you to practice a bit more before I introduce the second part of this section. So go to 18. So 18 is just a 12-sided die, right? So numbers 1 to 12. Paying attention, right? What does it mean to roll a multiple of 4? That means that you start with that number. So it'd be a 4 or 8 or 12, right? So you're going up by 4 at a time. That's what a multiple is. That's a good review, eh? What was that the last time you heard that one? 8, grade 8, 9, somewhere in there. So multiple of 4. So I ask for odds and I put probability kind of next to it. But multiple of 4 is still saying we're talking about the same event. I do have multiple of 5 as well. So that's just 5, 10. You cannot pick 15 because this die only has numbers 1 to 12, right? So it's within your total that you have to deal with. That's page 18. I want you to do that. Then I'm going to skip 19 for now. I thought I had cards as well. Forgot cards. Anyways, we can still, and page 20. So page 18 and page 20 right now, it should not take you that long, right? So let's answer that as much as we can. If you don't know one, still try it. Ask me if you feel like you want to know right away, but I am going to go over it. And then, guys, we're going to do the other way, going from probability to odds. Okay, we're going to go the other way. So I need you to first practice this. So 18 and 20. 18 and 20. So I quietly did my work while you were working or checking your Facebook status, Instagram. All right. Right, you can reduce pretty much anything here. This would be 2 goes into both of them, that's 5 to 1. Right, 2 goes into both of these, that'd be 1/6. It's fine, right? Right now I'm not focusing on that. I'm focusing on, do you even know how to get the right numbers where they belong, right? So keep in mind, I just want to add, this could have said the probability against rolling a 5. Then you would have taken, right, the against part, which is 10, right? The not getting a multiple of 5, so it'd be 10/12, right? So just read carefully and you'll be okay. Let's go to 20 here. The odds against, I'm going to highlight a lot here. The odds against Mr. D giving an AC, right? So that's the event we're after. Because of that word, which one of these stands for ACs actually? If it says against ACs, that means that this is ACs and this would be not AC. Okay? Because of the wording, the ACs are on the other side of the fence, so to speak. Okay? A student sees this and, it's supposed to be and, I already fixed it, and claims that it is unlikely that Mr. D gives out an AC. Is this claim correct? State the probability that an AC will be given on any given day. Okay, probability of AC, you know what? You would get partial marks if you just add these two up already. Just get it in, right? Like add them up. That's your total. And then you'd have to read based on what happens before you determine that the right side, the 3 is ACs. Okay, I'm going to put an arrow and make it go there. So that's 3/5 as a fraction. Decimal would be 0.6. Percentage would be 60%. I picked easy numbers for this one, right? Justify whether or not the student's claim is correct. It's more than 50% chances of getting an AC, right? So you would actually say the student is not right. Okay? The student's claim is incorrect since the probability of Mr. D giving an AC is, what would you say after this? Finish the statements. Like if it's supposed to rain, if it's more than what percent would you say the chances are higher for rain than not rain? Let's say over 50%, right? If it's anything above 50%, then the likelihood is actually higher for it happening than it not happening. Is greater than 50%. That's why the weather network will never put 50% chance of rain, because then you might as well just toss a coin and figure it out for yourself, right? They'll always go 40 or 60, or right, they will go 20, 30, whatever, but they won't give 50 ever, because then it's, why do you need them for, right? If you can narrow it down a little bit for me, right? So 0% impossible, 100% would be certain, right? Anything in between, right? This would be obviously 50-50, and anything here is likely, and this is not likely. Okay, I just came up with that now. Hopefully that helps. But anything, right? The 50 is kind of like your halfway mark, and then It's a bit more likely. If you're comparing events, you would look for the highest percentage. Right now, 50 is kind of like it's greater than 50. It's somewhere in the 60s, so it's more likely to happen than not. Okay. Never leave one of these blank. Just give me something, and I'll try to squeeze out some marks. Okay. But be specific. Right? Try to be specific. Don't be like politicians. Right? Generalizing everything. It's gonna be better. I'm gonna make things better. It's like, well, what are you gonna do? Give me the plan. Right? Trigonometry. Consider the letters in this word. Right? If you cut these up and you put them in a bag, determine. It's classic probability scenario. The probability of drawing a T. Probability of T. How many T's are there? There's one right there. There's one right there. There's 2 out of. Gotta count letters, right? 2, 4, 6, 8, 10, 12, right? Total would be 12 letters. So when you have a probability scenario, you somehow have to come up with the total. So it's 2 out of 12. Okay. Let's reduce this. Right? Divide by 2, divide by 2. 1 over 6 is the better. What about odds of drawing a T? Odds of drawing a T. I'm gonna do it based on this. So 2 T's, and on the other side, I'm done, Mr. Dirksen. Next, you have a total there. That should raise a flag here. You can't have that. So it'd be 2 to 10. There we go. 2 to 10. Or let's use this one. 1, and on the other side, 6 minus 1. So it'd be 1 to 5. Which one is right? The answer is both, right? Both are correct. It's either using this probability or using the non-simplified. Right? That's probability of drawing a vowel. That's A, E, I, O, U. I don't know if you remember that. That's the last time you've used that. Right? But that's actually classic probability. So probability of vowel. Let's count how many there are. There's 1, 2, 3, 4. Y is not a vowel. Okay, so 4 over 12. There we go. The odds of drawing what's consonant? Whatever is not a vowel is a consonant. Okay, so probability of C. You have options here. You could just say what? 8, right? You could say 12 minus 4 over 12. That'd be 8 over 12, right? If 4 of the letters are vowels, then 8 of them are not, right? Meaning they're consonants. It's kind of like saying not winning. It's the same thing as losing, right? Oh, sorry. You're right. I'm wrong here. I'm kind of getting there, but yeah, odds. So this is my bad. So you want 8 to 12 minus 8. 8 to 4. That's what you wanted there. My bad. Good catch, Kenneth. I'm gonna leave it here. Can do page 19. You still have what, 5 minutes? If you want to do page 19, if you want to just rest, that's fine. We're gonna do the next part tomorrow, but I will probably have an AC on what we did today tomorrow. Okay. All right. Have a good one.